So what 2.2 is you're learning how to use your calculator to work with degrees. You're learning on you're doing the prep for the application of Trig. Trig is a big puzzle. It is a big application problem. You will do more application problems in Trig than any other math class because that's what it's set up for. So the first thing we need to do is know how to convert between degrees and decimal degrees, minutes, seconds. A decimal degree is what it says. It's a decimal. Okay. So far you haven't used decimal degrees. You've used whole degrees. So you weren't in either one. Have you ever heard on a movie that we need to go 25 degrees, 16 minutes south? Ever heard that? It would be in a navigation scene. If it's a plane, if it's a ship, if it's a spaceship, okay? The further you get, you have degrees, minutes, seconds, milliseconds, nanoseconds. I'm getting smaller and smaller and smaller. Okay, I don't need nanoseconds when I'm on the Earth. Where would I need nanoseconds? Where would it be more important to be more accurate with your navigation? Space. Because if I'm going from this point to this point on my piece of paper, and I say this would be north and this would be east, yes? Okay, so if I said go 30 degrees, well, that's probably 50 degrees. 50 degrees northeast. Well, northeast, 50 degrees. If I'm not exactly right, am I going to probably hit this point on this piece of paper? Yes. But what if I was standing here at school and I'm trying to give you directions to my house and I said, okay, face east and then turn to your right 50 degrees and walk 10 miles. What's going to happen if I'm off by 10 degrees? I'm going to get, instead of going towards my house, if I'm off by 10 degrees, I could be clear over here, couldn't I? The further I go. Okay, so if you're on a boat and you need to go 200 miles, not 10 miles, and you're off by 1 degree, is it going to make a huge difference? Yes. So we need more precision when we're talking about navigation. Okay? So when you have application problems, you're going to have navigation application problems. So you need to learn how to do this. So 1 degree equals 60 seconds. So this is seconds. What does this remind you of? 1 what equals 60 seconds? 1 minute. Okay, so that's the conversion. So when you're doing math with time and you're doing 60 minutes, you have to borrow an hour, right? And when you borrow 1 hour, it turns into 60 minutes. So math is going to be like that. 1 second equals 1/60th of a degree.
Can I flip them around?
Oh, this is minute, not second. Sorry, guys. Because I got to go minutes, seconds, and I don't know why I went. Thank you. Should have yelled at me. Okay.
Can I flip them around?
Flip what around?
1 minute and 1/60.
Oh, I don't care. So 1 minute is how many seconds? 60. So 2 is seconds. So 1 second is 1/60th of a minute. So your magic number is 60. You're either multiplying by 60 or dividing by 60. Now, we are only going to go as far as minutes, seconds, but know that they do have, if you would see anything with aerospace, they would go much further than seconds. Because in space, you're not going 100 miles, you're going 100 million miles or whatever. You're going huge amounts. And you've got to be pretty accurate with that, unless you not even going to be close. So if I have, I'm sorry, does everyone got that? Okay. So some examples of how this would go. We have 52 degrees, 10 minutes. And that's how we'd say it. We'd say 52 degrees, 10 minutes. Okay. How would you say that?
5 degrees, 27 minutes, and 30 seconds.
Yes. 5 degrees, 27 minutes, 30 seconds. We will convert them into those, but right now I just what it is. Okay, and this one would be
13 degrees, 24 minutes, 15 seconds.
okay. Does that make sense to everyone? So again, this section is to prep you to be able to solve application problems using degrees, minutes, seconds. So we're going to be doing some math with these. We've got 48 degrees, 49 minutes, plus 72 degrees, 26 minutes. So, again, I said it's the same as time math, right? Do we have to line up units? Yes, you can only add seconds to seconds, minutes to minutes, degrees to degrees, correct? Okay, so this would be what? 5, carry a 1, 7, 0, carry a 1, 12. So, could I write my answer 120 degrees, 75 minutes?
No,
Why?
because max minutes is 60.
The max minutes is 60. So how do I fix that?
Take 15 from the 75 and get it to get 1 of the degree.
Well, I'm going to subtract 60. So I subtract 60 from 75 and add 1 to my degree. So it would be 121 degrees, 15 minutes. You would have done it right. It's just the way you said it.
Why did the other 60 get?
That's I took 60 seconds away and made 1 degree.
Oh.
Why'd you make a degree?
Well, because you have 75 minutes and the max minutes is 60, right?
Yeah.
Okay, so what if I want to subtract them? I'm going to do it the other way around. So I have 72 degrees, 26 minutes, minus 48 degrees, 49 minutes.
Can you borrow the same one?
I have to borrow, don't I? But I'm going to borrow 1 degree, but it turns into how many minutes? 60. So this 60 plus 26 would be 86. So I had to borrow 1 degree, but 1 degree is how many minutes? 60. Is that exactly what you would do if you were doing minutes on a clock?
Uh-huh.
Yeah. So now I can subtract it, right?
Yeah.
So 16 would be 7, 7 would be 3. Then borrow, so 11, so 3, 6. I get 23 minutes, 37. 23 degrees, 37 minutes. How about you guys?
Yep.
Okay. So these, when I'm telling you these units, these are called degree minutes. I don't know if that's hyphened or I kind of say it like it is. Degree minutes. There's no decimals there, are there? Okay.
I didn't do that right. So.
What didn't you do right? Did you just mess up or do you have a question?
I think I did because why did you say 86?
Because I borrowed 1 degree, so I had to add 60 to the 26.
Why did you borrow a degree?
Because I can't take 49 from 26.
Oh, okay.
Okay. Everyone else okay? Are we good now? Okay, and you good now?
Yeah, I'm good.
Okay. So we need to convert because at the beginning I said we're going to convert between decimal degrees, degrees, minutes, right? So our magic number is 60. We're either going to multiply by 60 or divide by 60, depending which direction we're going to go. So we need to change 27 degrees, 27.25 degrees. Okay, so if this was degree minutes, this is decimal degrees. Everyone needs to understand the difference. Why is this a decimal degree? Because that's a decimal. This is degrees minutes because it's degrees and minutes. Everything else you've been dealing with is like 23 degrees. Which one is that? Just 23 degrees. Which one is that?
What?
Like everything you've been dealing with till today is this 23 degrees. Is it degrees minutes or is it decimal degrees?
A minute.
Maybe either one because it doesn't have anything smaller than a whole degree. We don't know what we were dealing with. Okay. So I need to take this because what this says is 27 whole degrees, correct? Plus 0.25 of a degree. That's what that says, yes? Okay. So I'm not going to mess with the whole degrees. I'm only going to mess with the parts. So when I go to a decimal degree, when I go to a degree minute from a decimal, am I going bigger or smaller? A
Smaller?
0.25.
0.25 is 60.
Aren't I going bigger?
Oh, okay.
I'm going 0.25 to 37. Aren't I going bigger?
Mm-hmm.
So when I want a number to go bigger, do I multiply or divide?
That's fine.
Multiply. I want us to think about that. I just want us to think about that. So if I was going, I'm going to multiply from degrees, decimal degrees to degree minutes. But if I wanted to go degree minutes to decimals, I would divide because I want to go what? Smaller. So what's my magic number again? 60. So I'm going to take 0.25 times 60. Well, a fourth of 60 is 15. So it's 27 degrees, 15 minutes.
I need to borrow a pencil.
And
I just broke.
so this is degree what?
Minutes.
Minutes. Does that make sense what just happened?
Yeah.
Now, what if I still had a decimal? You take that decimal times 60, and you wouldn't have minutes, you would have seconds. And we're only going minutes, seconds, so if you still had a decimal, you just round. Okay? So now we probably should go the other way. So let's go 10 degrees, 45 minutes. And this is what units?
Degree minutes.
Degree minutes. So I'm going to go to decimal. Well, decimal is divide because it's smaller, right? So don't mess with the degree. And you're going to have 45 divided by
It's smaller than what?
smaller. A decimal is a smaller number. So if I want to make a number smaller, I would divide.
Okay.
That's all I'm getting at.
So you're just trying to make it into a decimal?
Yes.
Okay.
Okay, so 45 divided by 60 is what?
70.
It's 75. So it's 10.75 degrees. And now what units am I in?
Decimal degrees.
Decimal degrees. Makes sense, guys? Okay. Okay, now we're just going to get used to using our calculators for things. We are not always going to use our calculators, but in application problems, we will eventually have to have an answer that means something to somebody, correct? You can't tell somebody, oh, the sine is 76 divided by 4. That means nothing. So we're going to have to eventually get good answers that somebody wants to see. So we are going to use our calculator. So cosine of 37.8 degrees. Please be putting those parentheses even though your book does not. It will help your brain. Okay, so how am I going to do cosine of 37.8 degrees?
Where do you put degrees?
Click cosine in the calculator.
Click cosine and put 37.8 and hit enter.
I could not find cosine for a second.
Just put it in right now. Don't worry about the degrees. It's on there, but I'm not going to show you where it's at.
Mine's different.
Okay.
Yours is different, Emma?
Yeah.
Mine is also different.
Yours is also different?
Mine's 0.79.
Yours is the same as mine? Sam, yours is the same as mine?
Suppose I'll check.
Mine's 0.79.
I know.
That's what mine is.
You know, Miss May?
I know it's wrong. I know it's different.
What does that mean?
Mine's
Wrong.
0.79.
No, what is
Okay.
it?
Olive and I are wrong. Sam's wrong. Okay, you guys kept asking me what. What did you keep asking me? What did you keep asking me where what is, and I wouldn't answer you? Degrees. I wouldn't answer you, would I? Okay, there is a degree symbol. See this button that says angle?
You set us up for failure?
Yes, I did. See this angle button? It's there. But this is an easy, like if you hit angles, hit second angle just so you can see.
Yeah.
Do you see a degree?
Yeah.
What else do you see? What's that?
Minute.
A minute. Okay, it's there. Oh, what does DMS stand for?
Do that, solve.
That's a degree minutes.
Degree, minute,
Seconds.
seconds.
Oh.
Okay, so there are things here you'll forget about it. You won't ever remember to use it, and that's okay. But it is there. But the easiest way to do that is when I got the wrong answer and we got two different answers. Usually that's a problem in the what? In the mode. So go to your mode. Everyone go to your mode. Sam, Olive, and I all have one thing in common. And Kyan, Emma, and Alex all have one thing in common.
Mine's set on degree and yours is on radian.
Yep.
Well, that's
Sam, Olive, and I are all set on radians. How would I know to have it in degrees? What am I putting in there?
Degree.
Degrees. So if I'm putting degrees in there, I need to have it on degrees. Now, if I would have done this and gone over here and gone angle and hit 1, I would have got the right answer.
Hey,
Okay, but I'm not going to do that every time, am I?
no.
So when you're dealing with degrees, make sure your calculator is in degrees. You haven't learned yet what radians is. It's actually the measure of a radius on the circumference of a circle. Radian, radius. Okay, and we will soon do that, and we will have to go back and forth. Anyone in physics in here? No, I keep asking that. Okay, if you're in physics and in here, you need to keep your calculator in degrees, always for physics, and in here it goes back and forth. I've had people be in physics and do a whole test and finally realize that their answers were just off, and they'd done the whole test in radians. But you also should write down all your work, right? So all they had to go back to, she wrote a note at the top of her test. My calculator was in radians, not degrees, and then went back and started doing it, like putting what she had. So she didn't have to do the math again. She just had to put it in the calculator again. So, but you do need to be conscious of that, okay? It's funny because physics is all in degrees, but if I go to graph, you can't graph in degrees. It has to be in radians. It doesn't, you can't, degrees are circles, yes. Graphs are flat, and you can't graph flat things, circular things flat. So that's how you do it. Okay? So everybody got their mode in degrees? No? Did you change yours?
Yeah, I did.
Okay. Okay, so now we can do it. Let's see. Tangent of 58.75. And I want you to write this on your paper, guys. You write the problem. Don't just write the answer just because it's good form. You should get 1.65. 4 decimal places it usually says. So 1.6499, right?
Mine's off by like 1 number. Mine's 1.647.
How did you get 9?
Because that 9 would make that 8 a 9. Did you put in?
Oh, you put 7, 8, Miss Smith.
Yeah, I was gonna say.
Oh.
Mine's only 9.
There you go. 1.6479. So again, garbage in, garbage out, right? If you're not getting the right answer, you probably did something wrong.
4 decimal points?
Yes. Sine squared of 14 degrees. Now, what is that really? And we're going to write this, and I would expect you to write it on your paper the way you're going to put it in your calculator.
Sine of 14 times sine of 14. Or no.
Just sine of 14, then what? Squared. So, parenthesis, sine 14, parenthesis, parenthesis, squared. So you should get 0.5852. No, 0.0585. Just disregard zeros that don't make any sense, evidently.
No, we don't.
Okay. What about the secant of 78 degrees?
Isn't that... Is that cosines?
Is it?
No, secant is sines. No,
No.
secant is cosine.
I was right.
It's so
Secant.
dumb that cosecant is sines.
No, because of the cofunctions. We just learned about cofunctions.
But that's dumb.
No, it's not. An S and a C. That's all you need to do.
Sine cosecant.
One S, one C. Okay. Is there a secant, cosecant, or cotangent on this calculator?
No.
No. So we probably need to use an identity. What identity would you need to use?
1 over cosine.
So on your paper, I definitely want to see 1 over cosine of 78. And if you guys don't do this assignment, I always see it bite you in the butt during the test because you'll come up and say, how do I put this in my calculator? And I'll look at you like, I'll be that emoji. Did you get 4.8097?
Yeah.
Okay. So, next. How do you guys remember how you use sine, cosine, and tangent to find an angle? So if I gave you the sine of theta equaled, I don't know why I went to sine, 0.3733. I cannot put that in my calculator, can I? Why not? Because theta is the x, right? You can't put an equation in your calculator, can you? You can put one side or the other. So this is my input, and this is my output, this is my domain, this is my range. So I need to do what with them? Like I need to switch them, yes? So what kind of function allows me to switch them? It's a specific kind of function that happens in every function. We even found them. You had to tell me if a function had it or not. We had to graph them. We had to find them. We had to verify them. The inverse. Doesn't the inverse function interchange domain and range? So the inverse sine, remember that -1? Of, it's on your calculator, isn't it?
Yeah.
Of 0.733 equals theta. So now can you put that in your calculator?
Yeah.
Yes. So the inverse sine of 0.3733. Do you remember doing that at all in geometry now? Okay, so this is an approximate, yes?
Yes.
And we're going to the nearest tenth. So 21.9 degrees. So I want the what?
I certainly don't have 21.9 degrees.
Did you put inverse sine
I did.
of 0.3733?
No.
Okay.
0.3733.
Garbage in, garbage out. Okay, we got two more we have to do. I want you to do this one on your own real quick. Tangent of theta equals 3.152. So you're going to write on your paper what? Inverse tangent of
3.152. 3.152.
Okay. And you should get approximately 72.4.
Mm-hmm.
Shh, yourself.
I don't know how you guys write something.
I need
What's the next one?
Okay. Oh, because I'm trying to get through this. Okay, secant of B. Okay, B just means a different angle, yes? Secant of B equals 1.0768. Okay, what's my problem?
You have to take 1 over the inverse or something.
Of what?
Cosine.
Uh-huh. So we're going to take 1 over the inverse cosine
Of 1 point.
of 1.0768. Now, notice how I wrote that. It's 1 over that. It's not, some people put inverse cosine of 1 over the answer. You have to put, does that make sense? Wait. I did it wrong.
Yeah, it says,
I did it wrong.
it says you have a domain error.
Yeah, I did it wrong. I did what I was trying to tell you not to do.
Is not allowed in the question.
So it's the inverse cosine of 1 over that. Sorry. Sorry, I wrote down what I was going to tell you not to do.
It's okay.
Okay, and you should get approximately 21.8
So, inverse cosine
of 1 over the answer.
the answer.
That's the answer. Like,
What the hell's going on with that?
Seventh
Sorry,
graders.
but what's going
I
on?
don't know. That's happens every day.
Not like that.
Okay, did you get 21.8 degrees? Okay, so today is not overly difficult stuff. Remember, today is training your brain so we can do other stuff. Got me? Because tomorrow we have solving right triangles.
E.O.O.
Every other odd.
Oh.
Every other
so
odd.
Like 1, 5,
1, 5, 9.
13,
Right.
17.
Because this stuff is just repetitive to get your brain doing the right stuff.